Hey folks, today we will talk about the properties. Because properties are everywhere in objects, and my talk is inspired by the Alexander Naumenko document about the cognitive model. And, but I want to talk about the properties more about in a scope of the semantic spacetime. Because in semantic spacetime, it's a method that allows us to describe any arbitrary information just in a four relations, and one of these relations has property. And I have a separate article about it, and I even wrote the book. But properties matter, and maybe properties matter even more than objects because. In LPG graphs, the property graphs, we just hide the property, and we see it as optimization because our graphs looks more compact. And we say that property are clunky and they make the graph more complex and the queries more complex and all other thing. And if we hide the properties, we actually win a lot of benefits. But the more and more I work in, I see the properties as a first-class citizens that deserve to be represented in your knowledge graph. And I will explain why. First of all, if you have the properties as a separate nodes, they could also form the subgraphs and relations, and maybe you could have more detailed relation how the different properties create the relations to each other. And actually, if we take a look to the neuroscience and how actually our brain process the objects and process the information, especially when we try to identify what kind of object we see. We start from the features and properties. We try to understand what kind of color it is, what kind of shape it is, and then based on the different configuration of the properties, in a scope of tasks that we add, in a scope of context that we have, we identify the different objects, and this process could fail and we could identify the wrong objects. But the concept that we see not the objects as a whole, but set of features actually create completely different opportunity for the memory organization. Because in programming, we quite familiar with this concept that if something is quacking like a duck and swimming like a duck and walking like a duck, it's probably the duck. And it's all about the feature extraction and the properties. And then we have some concepts of the polymorphic objects, inheritance, explicit hierarchies, because then we could operate with the clustering of graph based on the same property sets. And it's more remind me the object-oriented programming because we have the same paradigm there, but the forming of the cognitive and mental interfaces that describe some concept as a set of feature could be quite powerful for the organization. And also it's open us to more granular and more interesting queries. So maybe instead of hiding the properties in a node, we need to allow them to flourish, form the connections, form the interfaces. Maybe we should copy something from our neuroscience and feature detection brain, that the set of the properties also could form some kind of reasoning based on the properties. And it's not only the philosophical question that really write the books about the property of the object, and it's what's more important, property of object itself, but we need to be aware that even our brain actually when trying to identify the apple, see the color, shape, and all other sensory information. And maybe the answer for the richer recall and reconstruction when we try to find what's relevant, we need to ask the question what the feature sets are relevant to the context of the question, and then do completely different queries. So that's all that I was keen to share with you today. See you next time. Choose.